All right, thanks, thanks Nick Cassidy. And before I get started, I actually first want to thank all of you for being here and all of you for being so enthusiastic about TypeScript. It's just such an amazing community. This is our second event. Now we had the first one a year and a half later, and it's grown, and it looks like it's just going to keep growing. And this is like a total adrenaline shot for the people who work on TypeScript. So thank you very much for the trust you instill in us. And also, thank you so much to SitePen for doing all the work to put this conference on. It's a lot of work. There's no doubt about that. I also want to thank them for the swag. I'm wearing my TypeScript socks. Yeah, I love those. And yesterday they were handing out the speaker swag, and of course, I love the dad joke aspect of the speaker gift is a speaker. Anyhow, so I'm here, of course, to talk about TypeScript. This is sort of how I've broken down the talk. First, I'm going to talk a bit about why we're doing what we're doing, and what we're doing, and how we're doing it, and then talk about the community. Then what's new in TypeScript since we last met a year and a half ago, and then what's coming up next, and then I'm going to wrap it up. I'll end up doing some live coding eventually here, but I got some slides to get through first. Now, this, in a nutshell, is why we're here, right? JavaScript is a great language, but it has issues, and it needs tooling if you want it to scale. And really, that was sort of like the insight that we, and not just we, but many had, years and years ago, and that was in a sense what got us started. TypeScript is about adding static types to JavaScript. And once you have static types, you can build great tooling, and that's really the business we're in. We also do transpilation, but that's pretty much it. This month is our 7th birthday, believe it or not. TypeScript is now a first grader. It's been a journey in so many ways. When we started, the world looked different, the internet looked different, Microsoft looked different. It's been such an arc, such a learning experience for us about open source. We knew that we wanted to be open source, but we didn't know how to do open source, and we did some wrong things in the beginning. We put our code on Codeplex, which was all crickets, and it took us 2 years to move to GitHub. But I think we've gradually gotten it right, and it's been such a phenomenal learning. And we've sort of, by now, distilled it down to these 6 sort of operating principles that really have been the case for the last several years now. It's about doing open source, but also about doing open development. As I said, we started out on Codeplex, and it was really sort of more like lobbing the source out and then scraping the issues from there and putting it back into our internal issue tracker, and that's not really open source. And so 5 years ago, a little over 5 years ago, we moved to GitHub, and that's when things really started to happen, and that's when the entire development team started to work in the open on GitHub. And it was also when we engaged with Google and Angular, and when things really started taking off. We see it as our objective to closely track the ECMAScript standard. We're not here to invent new statements in JavaScript or new expression operators or things like that. Rather, we just want to track and provide implementations of, and of course participate in the ECMA standardizations process. But where we do see ourselves having the ability to innovate is in the type system. And TypeScript's type system started out being fairly simple, but over time has gotten pretty advanced, I would say. In fact, I don't really know of any type systems that capture all of these in one. There are many that capture a few of them, but this notion of erasable and gradual typing, a structural type system that's generic, lots of inference, lots of expressive operators that actually are specific to how JavaScript behaves, and then being both object-oriented and functional is it's pretty rare. On top of the type system, because we have static types, we can build better tooling. I've always felt that, you know, there's only so far you can go without the user giving you more of an indication of what things are. And static types are a deep enabler, and it really is, when you think about it, like the reason we can do statement completion, code navigation, go to definition, refactorings that are safe is because of static types. So it's a tremendous enabler. We also see it as our job to continuously lower the barrier to entry. You no doubt noticed how we do a lot of work now to make TypeScript the language service for JavaScript. And really, even if you don't want types, we can actually deliver tremendous value. And then finally, community. And that's, I'll talk a bit more about that. Just recapping the last 18 months, you know, where we've gone. We've had 1, 2, 3, 4, 5, 6, 7, 8 releases in the last year and a half. And I've overlaid it here with the download numbers from NPM. When we met last at a year and a half ago, we were just over 10 million downloads a month. Now we're just under 30 million downloads a month. Comfortably more than 1 million downloads every day, every workday. Now, of course, that doesn't mean there's like 1 million programmers like every day downloading. It's obviously a lot of auto-provisioned stuff, but it does show how deep we've gotten into the fabric of the community, which is pretty cool. There was, in the past year, some really interesting surveys that I think even surprised the surveyors. NPM did a big survey of their user community and discovered that more than half of their community uses TypeScript, which actually, that totally floored me when I saw that statistic. That is truly just amazing. There was likewise there's a survey that gets done every year, the state of JavaScript, and this is a very, very big survey. I think they have 25,000 participants. And they also found that, you know, depending on how almost 50% use TypeScript, and almost more than 80% say that they want to use TypeScript, either are or want to. So that's great. On GitHub, TypeScript has moved into the 7th place of top languages. I am, of course, personally a little bit ambivalent about who we have to pass next in order to advance, but I actually wouldn't even be surprised if we have surpassed C# at this point. This is the team that builds the product. We just took this picture a couple of days ago. We're now in building 18 on the Microsoft campus. Few people were out sick. Sorry, we'll have to Photoshop them in, but this is it. It's a small team. It's less than 20 people. Most of them are here today, so if you see them, go say hi, go talk to them, and go figure out which part of the product they work on. I'm sure they'd really appreciate it. So community. Community is super important to us, and really, we knew that from the beginning of the project, but we sort of didn't know how to engage. I think we've gotten a lot better about it over time, and I'm going to give you some of the examples of community efforts that we have worked on for the last year and a half. One of the big ones is Babel support for TypeScript. You're all familiar with Babel, no doubt. Indeed, if you're using React, there's no way you couldn't use Babel. That's typically the transpiler that's used there. But we sort of, because TypeScript was also, always has been, both a checker and a transpiler, there was sort of like this sort of back and forth about, well, if I have to use TypeScript, then I have to switch to using a new transpiler, and I don't want to do that. And so we actually worked with the Babel team and put some of our resources on a pull request that for Babel to support TypeScript syntax. So the ability effectively to erase all of TypeScript's type syntax and annotations. And now it's possible, and indeed many people do, use TypeScript as their type checker, but use Babel in their build pipeline. So I think that's really a great piece of work. Another collaboration that we've done over the last year is ESLint. Early on, the Palantir guys built a project called TSLint, a linter for TypeScript, which became quite popular and was in there was a lot of use of that, but the ECMAScript community at large was converging on ESLint, and really it doesn't make sense to have two linters out there. And so we all, actually along with the TSLint contributors, worked on adding TypeScript support to ESLint, and that's in today. In fact, we've switched now. We use that in our build pipeline, and it's also actually can even bring some performance enhancements because ESLint is built in a way where it doesn't do multiple passes over the ASTs, and that actually allows you to go a little faster. I think it's also interesting that because TypeScript can parse just JavaScript and do a whole bunch of inference, you can now actually have semantic lint rules just for ECMAScript, even if you're not using TypeScript. So it actually enriches ESLint as well. We try to sort of be the, if you will, the Switzerland of frameworks. We're not for one particular framework. It is indeed true that we worked early on with the Angular team, but today Vue is using TypeScript. Vue 3.0 is written in TypeScript. React is not written in TypeScript, but React CLI now does support TypeScript. So there are supported experiences on all of these frameworks for TypeScript, and we're very committed to continue to just work with anyone to make the experience as good as possible. We have lots of quick starts on our website, et cetera, et cetera. Another wonderful piece of community work is the playground. We had a team member join us last year, Orda, and Orda's first task has been make the playground better. And the first thing he did was get rid of the old code and go with a much better implementation from the open source community called TypeScript Play. And that is now what powers our playground. And one of the wonderful things that we picked up as a result of that is the ability to pick a version of TypeScript that you want to use, including the nightly, which means you can see before you submit a bug, hey, has this already been fixed? You know, let me just try with the nightly. And Orda is committed to just lots and lots more improvements here. One of the things he just showed me was automatic type acquisition. So when you're writing examples, we will automatically go find the declaration files for your imports and automatically provision them. And this is all happening in the browser. It's truly amazing, actually, what you can build in a browser. There's no server that has to run and like serve up the answers here. It all is done locally. And of course, you can't talk about community without talking about DefinitelyType. To me, this is such an interesting phenomenon. I think it is OSS at its very best. Did you know that we shipped TypeScript just over 7 years ago in October of 2012, and within 4 days, someone set up the DefinitelyType repo. A guy named Boris Yankov from Bulgaria created this site and started collecting type definitions, and there was not a whole lot there in the beginning, but gradually it grew and it grew and it grew, and it has gotten enormously large now. It is, in fact, amongst the top 10 most active repositories on GitHub. I mean, look at this. There's almost 10,000 individuals have contributed to this, and it's a treasure trove of information that just keeps on growing all the time. In fact, I saw this tweet, I thought it was funny, you know, that I hadn't been using TypeScript for several years, and now I'm surprised that you can just like pretty much get types for anything off of @types. And indeed, Nathan from our team did a bit of research on, you know, because we were trying to quantify, well, how many things are typed out there these days? And it turns out that if you just take all the NPM packages that exist, and there are a lot, it's actually, I think, under 1% has types. But if you look at all of the NPM packages, the dependencies of all of the NPM packages, how many of the packages that packages depend on have types, it turns out that it's 70%, which means the common libraries, the ones that we all use, actually do have tremendous coverage, and it's grown from 50% over the last couple of years. So that's the blue line there. The red line is how many of these types came from DefinitelyType versus were delivered with the framework or the package itself. And you see how that's actually declining now, which, well, you can read many things into it. I am guessing that it's because a lot of the frameworks are actually starting to write in TypeScript, which means they can now provision the types automatically, right? I mean, you don't have to put them somewhere else. And finally, that's the orange line. The yellow line is out of those that had types for all of their dependencies, how many of them had a perfect hit rate where all of the dependencies had types? And that's as high as 30% now. So that's pretty cool. We also, Nathan likes to run statistics, so, so we also ran some stats on, of all of these types, or all of these packages on DefinitelyType, how many types do they create? Because one of the things that can make our compiler slow is when you generate lots of types and start relating them structurally, and then that instantiates more generic types and yagity yagity. And I showed you the turtle slide last year with, you know, turtles all the way down, because it just, we are a perfect generator of lots of work if you try to get too creative, right? And so Nathan found that the top 1% of packages consume more types than the bottom 33%. So most of them are not, but you see that spike out on that's when you get very creative about, like, oh, let me try to use index access types and conditional types and like do fancy, you know, things. When I dot, then I intersect more things onto there and so forth. And that can very quickly explode. I mean, we've created a very powerful monster in a sense, and so I ask that you be careful. You know, use the powers judiciously. We even have this. God, I don't really know what this Gini coefficient thing is, but anyway, here's the workload on DefinitelyType. And this is interesting too. You know, in the beginning, this goes all the way back 7 years. In the beginning, as you can see, there was not a whole lot happening. The first big spike is when Angular adopted TypeScript, and all of a sudden, like, interest just doubled overnight in TypeScript. And then the next spike is when Microsoft decided to, when our team decided to actively involve ourselves in DefinitelyType. It had gotten to a point at, you know, where we had like TSD and typings were the ways you could sort of install types, and the whole acquisition process was very ad hoc, didn't version well, errors were, I mean, and everyone was complaining about how hard it was to configure TypeScript correctly. And so we decided to apply some engineering to the problem. And Ryan, who's now our dev manager, spent, I must have spent at least 6 months on just this. We set up the @types namespace on NPM. Ryan ran stats on all of the packages that were available at the time, got them all into a uniform shape. And we built bots that we run in the cloud that react to pull requests on DefinitelyType, automatically packages up the types and deploy them to NPM. And in fact, that workload has gotten big. We also now have bots that tag pull requests as they come in, forward them to the committers, et cetera, et cetera. In fact, we run what we call the DefinitelyType rotation in our team, where each team member has to spend 1 week nursing along DefinitelyTyped. And that means, you look here, there's like this is just one morning, right, where there's like 27 PRs waiting for reviews, and someone's got to look at them, and often the committers are missing in action, right, or the maintainers are missing in action, and so So in fact, Nathan did a presentation to our team internally about the whole process, and I love this slide that he put up. This is what it feels like to be on DefinitelyType duty. You have to merge one pull request per hour for the entire week, you know, and they just keep on coming. So my appeal here is, please help out on DefinitelyType. If you are a maintainer of something, or if you think you can maintain something, you know a lot about a particular framework, you know, we sure would appreciate your help. Actually, and if you're interested in more history on DefinitelyType, Johnny Riley wrote up a really beautiful write-up of the story of how it came to be and how it got to be where it is today. So go check that out. Okay, I also want to just do a shout out here of thank yous to our community for all of the things that they built. In fact, in the latest upcoming release, 3.7, two of the main features are community contributions that we did help out on them, but they were mostly built by community members, and that's just wonderful. Okay, so let's talk about what's new over the last year and a half. And really sort of the features that we've done in that year and a half have fallen into, I'd say broadly, into three buckets. We've focused a lot on improving the user experience. I'll show you some examples of that. We focused on scaling and faster builds, and we focused on better capturing functional paradigms, which are very popular in frameworks today. Why do you think I'm showing you this? Because error messages, the pyramids of doom, you know, it turns out we're pretty good at finding out problems, but we may not be super ergonomic in presenting the problems. We try to give you all of the information, and sometimes that is just way too much, right? So one of the things that we focused on is like trying to make this a better experience, trying to point you at the problem. And that actually breaks down into a whole bunch of things like doing related spans, improving excess property checks, and so forth and so forth. And and plus adding a whole bunch more quick fixes. And so I'll show you some examples of what we've done over the last year. Here's the state of, or the last year and a half. Here's the state of 2.9, which was right before 3.0. And this was sort of the experience you'd get if you passed a wrong object literal that's deeply nested to some function. And sure, I mean, the information is there, and it's not that it's incorrect, but you know, really all you care about is that bottom line down there that may have even scrolled off the error message, right? And so in 3.0, and now therefore also in 3.7, this is what the experience looks like. We drill right into where the problem is. We tell you numbers are not assignable to string, so that's A. And then B, we show you a related span that allows you to go to the declaration of the thing. So if you're going, well, why is it a string? Well, then click on that link, and it takes you right to the declaration. We got a lot of people really like this one. I do too. Here's another one, a little more subtle. Union types are, you know, obviously a key enabler in our type system and is very heavily used. And here's an example of what can happen if you say have a collection of T that can either be an array of T or a map of string to T. And then let's say you are assigning to a collection of string, and you're assigning an array of number. And, well, numbers and strings are not assignable, so we sort of start out, yep, number array is not assignable to collection of string, it's not assignable, and then we go, number array is not assignable to map of string, comma string, because the symbol.to, what? So we basically run right down the wrong track there, right? Because it used to be that whenever you're assigning to a union type and it doesn't work out, then we would just elaborate into the last type of the union type, which, I mean, now what we do is we try to figure out, well, which is the best matching type, and then let's elaborate into that one. And obviously here, it's array, so now we elaborate into array, and we actually end up telling you what the problem is, right? So that's another subtle one. We do similar things for overloads. We try to find the best overload, elaborate into that instead of, you know, going off track right away. Here's another one. I mean, this one maybe not so hard to figure out what the problem is. You're forgetting to call the function, but you know, if that sits at the bottom of a pyramid or somewhere, you know, it might. But then just adding this, you know, little, hey, did you perhaps mean to call this function, you know? And then because we can see that, you know, number would have worked, but you had paren arrow number, right? So these are just examples of what we do, and there are many more. And you know, whenever you find a bad experience, please let us know and suggest what you would have liked to see instead, because chances are we maybe can do something. Okay, another theme over the last year and a half has been scaling and faster builds. In fact, it goes all the way back to 2.6 was when we first started looking into this, and I'll sort of take you through a number of the things we've done. How many of you use watch mode sort of on a regular basis? Yeah, fair number. This is sort of the ability to have the compiler sit in the background and watch for source file changes and then kick off a compilation whenever something changes. And we've had file level incremental watch for a long time. Here's like, say, a web of files and their dependencies, and let's say I modify one of the depended on files. Traditionally, we would just watch for all the files in your project, and the minute something changed, we'd wait for like a second or a half a second, kick off a compile of everything. And of course that works, but we're redoing a whole bunch of work here that we don't necessarily have to do. So in 2.6 we got smarter about it, and we actually, if you're writing modules, which i.e. if you're writing modern JavaScript, we actually can easily know what things you depend on by looking at your imports and their imports, right? And so we can actually restrict this to only recompiling those things that depend on you, and leaving the rest alone, and just caching all of the error messages that they had created. So to you, it appears like we compiled it all, but we actually only go look at it. And indeed, if we can discover that the external interface of the module that changed didn't change, it was actually only a change in the implementation, well then we only have to recompile that file. And that's been built in for a while, and that definitely has made watch a lot faster. But when it comes to scaling and better performance, another thing that was problematic was when you have large mono repos, which lots of projects do, often there isn't just one deliverable that comes out of that repo, right? When you build it, you're building many things. For example, you might be building a client side and a server side of an app that have some shared stuff at the bottom, but other than that, they're separate. And previously, we didn't really give you a way to set up different outputs. You had to manually go structure this, and then you had to manually use a build tool to write down make-files or the equivalent of that, you know, gulp or grunt or whatever. And that turns out to be complicated. So we started a work stream that is still ongoing, centered around what we call composite projects, where we allow your TSConf files to describe that they depend on other projects. And so you can actually sort of build a web of, or a hierarchy, I should say, of dependent projects. And then we have build mode in the compiler that allows us to be smart about building these composite projects in a speedy manner. Now, inside of these, of course, we also then have the incremental capabilities of files. So this sort of layers on top. Now, the latest thing we've done then is speeding up subsequent builds. Now, if you think about when you first start the compiler in watch mode on, say, a mono repo with a whole bunch of composite projects, well, the compiler knows which projects depends on which projects, but how does it know whether they're up to date? Well, now it has to sort of go like look at all the files. It has to resolve all the modules, and module resolution in Node, as we all know, is like can take many steps, and particularly if you have symlinks and remappings and da-da-da-da-da. So just actually figuring out like where things are takes a long time. And what we're doing now in the compiler is we dump all of this information. Once we've figured it out, we dump it into these .buildinfo files that you may have seen if you use Composite Projects. And then the next time you start the compiler in watch mode, we can go, oh, there are buildinfo files. Let's just suck them up. And now we're ready to go pretty much immediately. And that means we sort of go from cold to hot very fast, as opposed to having to do a full compile in order to reconstitute the information. So some examples of what kind of speed up that cost that gave us on Visual Studio Code. We went from typical builds taking around 50 seconds down to actually more like 10 seconds because most often there are no API changes and you're really just changing one module. I thought I'd actually show you on some real-world code. There's this project called Jester from Facebook that uses Typescript, and let me try to fire up VS Code on this and show you what it looks like. It has a whole bunch of packages in here. It's a big mono repo, and these are all projects that Composite Projects. For example, the main Jest project itself, if we go look at the TSConf for this guy, you see that it depends on the CLI and on Jest core. And if we click into Jest core, you see in turn that it depends on a whole bunch of projects, including, say, Jest util. And if we click into that, you see that it depends on Jest types. And if we click into that, now we're at the bottom. So we have sort of a hierarchy of dependencies in here. Let's try to go to the actual a folder for that thing, and let me try to do a build. I've already done a build of the entire project. A full build takes about 2 minutes, so I'm not going to do that right here. But now I'm just going to start off. The compiler is cold, it's not running at all, and I'm going to do the equivalent of a full build. And you'll see that actually, let me try and do it again. A full build here, 1 second, or even typically it's less than 1 second. And this is because we have these buildinfo files that we can go slurp up and very quickly understand what is everything resolved to and what do we need to go check, and then we can do the checks real fast. So let's try to actually make some changes here in, let's say in Jest util. Let's look at index.data.ts here, and you'll see here, let's go in to, for example, the clear line guy, and let's just try to add one line of code that doesn't do anything. Stream.write, quote, quote, like that. And let me try and save it. And let's go back and build. Now, this was a change that only affected one file and did not affect the external interface. So if I build, you'll see it rebuilds Jest util, and then the rest doesn't have to do anything because we know. And so in 3 seconds, we can get that done. And again, if I try to build again, now we're down to less than a second. But if I pick a file that does have something external, for example, let's try to go to special cares here. And let's try to add one line here, export const foo equals 42. And let's try to build this time. And now you see we need to build utils, but we also need to build other things. But still, it completes in about 8 seconds. And then again, if I go again, now we're fast again. So this can save you a lot of time. And so if you're not using Composite Projects and you have a mono repo, do spend the time to check it out, because it really is a time saver. Okay, functions and immutability. That has been another big theme in our last couple of releases, and I thought I'd just now try to do some coding here and show you some of these things in action. I'll start with let's see. Let's look here. Can everyone see the code? Or do I need to zoom more? It's all good? All right. Let's start out by looking at Tuples. We can zoom up a little bit more. We've supported Tuples for a long time, but Before 3.0, this is sort of the state of the world. Tuples had to be fixed length. And so some of the work we did was to support optional elements in tuples, and also to support rest elements in tuples. Now all of these tuples are valid. And that, of course, is nice. But where it starts to get interesting then is if you write something like function foo, and now we actually also support the ability to spread tuples into argument lists. So if I write this, you may wonder, well, what does that mean? Well, JavaScript supports rest parameters, and rest parameters are typically an array, but a tuple is an array. It's just an array about which we know more. We know about the elements, which in turn means we actually know about what the parameter positions are going to be. So if I hover over this, you'll see that we actually know that this is a function that takes a string and then an optional number and then a rest parameter of booleans, and I can call it accordingly, so passing ABC, 42 or 32, and true, false, for example. But of course, I can also call it with the tuples that I have in my program here by spreading them in. So in a sense, we've sort of created symmetry between tuples and parameter lists. So hold that thought, and then I'll show you why that ends up being useful. So let's try to pick up, oops. Another feature that we did is variadic functions. A variadic function is a function that can take a variable number of parameters. And those are very common in JavaScript. And of course, once you really want to get strong typing to them, then you actually have to have the ability to reason about them in higher order form, where you don't know what the parameter list is going to be, but it's going to be some parameter list, and upon instantiation, you want to be able to figure out what that is. Take an example here, a very simple function that calls another function. So it's a function called call. You pass it a function and the arguments for that function, and it calls the function with those arguments. You'd think that is super elementary JavaScript, but you know, before 3.0, we actually had kind of a hard time doing well on this one. Let's say I had let x equals call of f0. As it's written here, there are obviously a bunch of any's, and really all I end up is with an any here, which is no good. We could of course do a little bit better about capturing the result type as a type parameter, and now we can infer that, oh, you're calling something that returns string, and therefore you get a string. But of course here, I could pass any random argument list I wanted to, or not pass any arguments even though the function requires them. So that's still not particularly good. Because we now support spread and rest parameters in higher order form, I can actually do something very interesting here. I can say, instead of saying that I take an any array, I can say I take a type variable that is an array of some sort. It could be an array, it could be a tuple, it could be whatever, and then my argument list is one of those, like that. And now, lo and behold, what ends up happening? Now we infer a tuple here. In this particular case, an empty tuple, but let's say I'm calling f2. You'll see that we give you an error. We say, hey, we inferred a tuple string comma number from the function you passed, and then we spread that in, and now we require you to give us an argument list that is A and B, but you didn't. So now actually I can even do better here. Now you get statement completion. In fact, you even get the parameter names from the function because we create a sideband in the tuple that we infer, and then we spread the parameter names back in when you use the rest parameter. So here we actually get a very nice experience all of a sudden. Now, you might go, well, that's fun. Well, but why is that interesting? Well, I mean, if you've ever used the built-in call operator or call method that exists on every function, then you will now all of a sudden have a strongly typed experience. So here I can actually call f2.call, and I get to pass the right parameters. And it's not just call, it's also bind. So I might say f2.bind, and bind, say, an undefined this, and then foo as the first argument. And now what I get back is I get now a function that takes a number and returns a string because I have bound the first argument. And so now I can actually say let z equals f of 42, or sorry, x of 42. And it all works out and is strongly typed. So that's sort of like an interesting example of how features sort of fit together, and all of a sudden we can capture in the real world some things that people do on a day-to-day basis. All right, so that's that one. Let me try to look at next is some of the work we did to support immutability. Here's just some simple code. I'm sure you're familiar with how when you use literal types like A here, but you assign them to a mutable location like S1, then we widen the type to string because you might later in the program have an assignment to S. So whenever we infer types for mutable locations, we go to the top of the domain of that type, even though you used a more specific type. But when you're inferring for an immutable location like a const, then we can actually preserve the exact type. And that's goodness, of course, but it can be confusing at times because of JavaScript. For example, if you say const circle, you would think, oh, well, then kind would be of type circle and radius would be of type 10, but no, it wouldn't, because properties in an object literal are mutable locations. We don't know that you're not going to go modify that later, and there's no indication that you're not, so we infer the widest possible type. That has been a bit of an irritant because the only way to get the literal types was to now manually write a type annotation, which no one really wants to do if they can get away with not doing it, right? And so based on community feedback and suggestions, we implemented this feature called Const assertions, where you can simply assert that I want the const form of what I wrote here. Give me the most immutable form of this thing, because I'm not going to mutate it. And look what happens now is we not only infer literal types, but we also infer read-only properties. And now you know, hey, this is going to be real hard to modify. It gets even better with arrays, because here, well, we don't really know what you mean. I mean, it's like, well, you put some strings and numbers into an array, so I guess it's an array of strings or numbers. But we don't even know what the length is. We don't, I mean, it could be anything, right? But if you add an asConst annotation here, sorry. Now you get a read-only tuple with exact types, and if you index into that tuple, like list sub 1, you will get the type 2, because we know that that's what is at that location. And I mean, it gets real beautiful when you get into this guy here, right, where this might have been what you meant, but RGB clearly, you know, it has the same shape every time, and so forth. But let's look at what happens if I say asConst. And now we actually get this, look at this beautiful type, where we actually know, whoops, let's try again. We know pretty much everything here. We know that there are 3 elements in the color array, and we know that code has RGBs that are tuples. We know what the exact values of the tuples are. We know all the string constants, et cetera, et cetera. So now when you use this in your code, it's actually super strongly typed. So that's another nifty feature. Let me no, let's not save that, and let's try to look at higher order functions, and we'll do a little geeking out on functions here. Let's say I wanted to write a function that composes other functions. So I want to write a function that can take 2 functions, and I want it to return a function that first calls the first function that I passed and then calls the second function on the result of that and then returns the result of that. This turns out to be one of the core things that you do when you're doing functional programming and functional programming libraries. Now let's look at how this pans out. Let's say I have a function that can get the name of a thing that has a name property and then another one that can get the length of a string. I can now compose these and I can say const length of name equals compose of get name comma get length, like so. And if I hover, you'll see that we have inferred a function that takes name, an object with a name property, and returns a number. And you can actually sort of follow how inference worked here by seeing that for the first type argument, we inferred the object type, and then we inferred string, and then we inferred number, and instantiated in. And that's, anyway, that's all pretty cool. But what if, and now this is where it gets fun. What if I have a function like this, first of all? Now, if you've done any functional programming, you know like a function called zip is a thing that takes two arrays and returns a single array of tuples with elements from each of the two arrays zipped together, right? That's what that could look like written in TypeScript. Let's say I also, let's say I have another function that takes an array of key value pair tuples and produces a map from those key value pairs. Turns out that that's actually the built-in constructor of map. Now what if I compose these? So let's say const arrays to map equals compose of zip comma new map. Oops. Like so. Now in the old days or in the pre-3.0 days, we would not do so well on this because you'd end up with a whole bunch of curly-curlies because we would erase all the genericity. We would try to infer actual types for the arguments, but that's not possible because I'm operating on generic functions. So I'm passing generic functions to a generic composition function. So what we need is higher order functional composition. And that's what we went and implemented. And so now you'll see that we actually infer here a function that takes two arrays and returns a map of those. And if I have something like keys and elements here, I can now write let map equals arrays to map of keys, comma, elements. And you'll see that we infer here, oh, you're going from string to HTML element, and out comes a nice little map. And all I had to do was just annotate the parameter list, and everything else is inferred. And this was a hard problem to solve. I'm proud of the fact that we managed to lick this one. So, thank you. Okay. Let me go back to the deck here. Here we are. And let's talk a bit about what's coming up next in the next version of TypeScript. What does this signify, you think? Issue number 16. What is that issue? It is optional chaining. In the next version of JavaScript, this is actually valid JavaScript through optional chaining and nullish coalescing, which are two of the features that are going to be in TypeScript 3.7. The optional chaining issue, number 16, actually is the most upvoted issue we've ever had, like 752 upvotes before we locked the issue. And nullish coalescing has been real popular, but we actually have some other things, some other goodies in the bag there, assertions, recursive type inferences, et cetera, et cetera. I'll try to do a quick demo of some of those. Let me get rid of this guy, and let's start with higher order chaining. And in fact, let me go here and start TSC-watch on chain. And then let's open up let's go here first. And let's open up chain. .js so we can see the output of this, and then let's split the editor there. Okay, I'm just doing a little bit of setup here so we now can see the output from compiling the first one. So here we have a person, and persons have names, and then optionally they have details, and the details optionally have an age and an address, and then I put in an X and a Y here that I need later. Okay, so let's say I wanted to access the city from a person today. I would have to write something like p.details, and of course that can be null, so now I have to check that, and then I have to say p.details.address, and then that could be null, so now I have to say p.details.address.city in order to fetch that out, which is painful, clearly. Now if I save, yes, you'll see that that's what we get. Now, with nullish coalescing, or sorry, with optional chaining, let's back up and see. I type p.details. You see that the checker knows that this is an optional field. I'm just going to type dot, and you see that there's an error now, actually, that you're trying. But if I autocomplete, it just changes the dot to a question dot because it knows from the types. And if I keep going here, dot address, and try to do city, it just completes like that. That actually is real beautiful, I think. Now let's try to save, and whoa, we get some interesting code. In fact, let's try to do const age equals p.details.age, which is not quite as bad. And then let's try to look at what we get here. You see that the code gen is actually fairly simple. We introduce a temporary for p.details, and then we check if it is null or if it is undefined. This is a succinct way of writing undefined in JavaScript. And if so, then you get undefined, otherwise you get c.age. And then the line above is really just composing the two, and therefore there's some parens around it. Now, of course, the next thing you can then do is you can go, well, age still, if I hover here, well, it still could be undefined, right? What if I want to get rid of the undefined? So I want to say const n equals, well, traditionally I might have said something like this. But can anyone spot the issue here? Does anyone have newborns? If age is 0, 0 is falsy, and therefore you're going to get -1, which don't ask me why that is, but it is. But now we have the nullish coalescing operator that only checks for null and undefined. So here, that is really the equivalent of saying if age is null or undefined, then give me -1. Otherwise, give me age. So that's, in a nutshell, chaining and nullish coalescing. I wanted to also, I see I'm starting to run low on time here, but I'm going to try to get as much done as I can. Asserts is another cool feature that we support now in Typescript 3.7. Let me actually not write it like that here. And then let's say I have a function test, and in here I write something like assert type of x triple equals string, comma, you did something bad if it isn't. And now I sure would like to be able to say x dot length, wouldn't I? But x is still of type unknown. And that can be sort of irritating, right? I mean, we've all written code like this probably. Now we actually give you the ability to annotate with what we call assertion predicates. So I can say that this function, yes, it returns void, but it also asserts that expr is true, or truthy, rather. And now the control flow analyzer will take that into effect. And so when I say x dot here, it actually knows that x is of type string. And that can be really nice when I mean, this is just sort of one added. But let's say instead I had gotten to a point in my code where I'm just like, okay, I've realized that things have gone bad here. So I'm failing. But then let's say that there's some code that follows after that. Well, that code is actually unreachable. And really, in a sense, it's an error to put code after a fail, right? But my fail function here, by default, we infer that it's just a void returning function. This could have just been throw not implemented yet, right? And you might actually mean to have it be a normal function. But if you really meant for this function to truly be treated as a function that never returns, you can annotate its return type as never, and you'll see that the control flow analyzer now picks up on that and now knows that there's unreachable code following this fail, and it would give you an error if there was code sitting there. Similarly, we've now gotten better at detecting unreachable switch ends of switch statements, where switches have all the cases handled, and therefore you never get to the end if all the cases return, and so forth. So that's another nice new feature in 3.7. Recursive types, I might just skip that one for now, but we basically allow recursive type inferences, so you can, well, I might just show you. I can't help myself here. Let's see. Recursive. Just the fact that you can now write down the type JSON and not get an error. That used to be an error, but it is now possible. And the next one down, the hypertext node, which is actually a recursive tuple type, you couldn't even write that. The other one you could sort of cheat and inherit from array and sort of make it work, but the second one, it wasn't even possible to do that. Okay, few more. Let me show you uncalled here. And let me actually show you, sorry, I should have switched to Typescript 3.6 here and show you the experience today. Users can be administrators, and we only want administrators to format the hard drive, yet this is just always gonna, can you spot the problem? Yeah, obviously. We forgot to call the function. We just check, and functions are always truthy if you don't call them, even if they return bools. So really, what I should have done there is I should have called the function, and we now have an error for this situation. And here we now tell you, this is always true. Did you mean to call it? Now, that's obviously that's nice, and if I do call it, the error goes away. But it turns out that we couldn't just leave it like this. When we ran this on existing code, we actually got a whole bunch of false positives. And you might go, well, how could that be? Well, sometimes people do defensive programming. They do have a property is administrator, but it might not have gotten initialized by the constructor, and they're not really, they're not doing strict property initialization and whatever. And so there are cases where things that couldn't be undefined actually could be undefined. And so people do actually write these guards. So the little twist on it is that we only report the error if the function isn't called in the body that is guarded by the check. But if you do call it, then the error goes away. I thought that was kind of clever. Okay, another, and then I think I am pretty much done with this guy. Let's first go back to 3.6, and let's try to say 01 equals 02, and observe the beauty. Well, that one is actually, that's fine, right? I mean, okay, that really is the type, but oh my gosh. This is obviously not super helpful, right? Now, let's see what happens in 3.7. We still have the same type, but look at this beauty here. We say this long type is not assignable to this long type because a.b.c.e.f.g are of different types. So we sort of condense down when the path is actually the same on both sides. And then we can very quickly get down to the bottom where the interesting fact is. So that's another one that's in 3.7. Let's see the one thing, how out of time am I? Do I have 5 more minutes, or am I done? Okay, great. Thank you. Then I'm going to show you, let's try to go to open web components here. This is a repo on GitHub that is all written in JavaScript, but they do a lot of JS-doc annotations in this code, and it turns out that when you have JS-doc annotations in your JavaScript, then you're sort of almost there in terms of making the development experience better for, let me actually open this guy here. Here's an example module from in there, a whole bunch of JavaScript with a whole bunch of JS-doc annotations, and here's like this, for example, this get diffable HTML function. And you can tell that, you know, even when you're using JS-doc, we can actually give you an experience that's very close to TypeScript. We can't go all the way, but we can get pretty close. And so here we know what the types of HTML is and what options is. And if you hover up here, we even have figured out like what type that JS-doc declared. But one capability we didn't have was producing declaration files from these things. And so in 3.7, we allow you to actually produce declaration files from JS-doc annotated JavaScript, which means you can get types for your JS-doc annotated. So if someone consumes it in TypeScript or themselves consume it in JavaScript using JS-doc annotations, then all of a sudden we can do much better. And that's so when you enable, this is the declaration file that we generated from that, where yes, all of the comments are still there, but if you look at the function declaration, you see that we've turned it into TypeScript. We actually have the real functions here, and we've inlined the functions as well that were referenced. So you see that there's a type diff options, and we've even slurped the comments from the JS-doc and put them in the generated type. So that's another 3.7 feature. Okay, and that I think takes me to almost the end. Oh, I did want to show you this one. Like Ryan loved this one when we discovered. So when we did the uncalled functions error, VS Code ran it on their repo, and they found 9 new bugs. And here's one of them. This is straight out of the GitHub repo, where they go file stats, and then, oh, if it's a file, then do this, else if it's a directory, then do that, else if it's a symbolic link, do this, except they never actually handled symbolic links, because they always ended up in the isDirectory branch because they forgot to call the function. So that is a beauty, I mean, isn't it? I mean, so that's the kind of stuff that we now catch. But you might go, but I don't like types. You know, I mean, I like coding in the raw. I like bungee jumping, whatever. But honestly, there is a valid viewpoint that maybe shouldn't say I don't like types, but it's more like I don't need types. I'm writing 10 lines of JavaScript. Why do I need types? Why should I have to configure? Why do I need a build step and whatever? And so, as you can tell, we're deeply investing in trying to make just JavaScript a better experience. And here's this one. I'm not even going to type. I'm just going to show you what it looks like to go into a blank directory, start a new JavaScript file called main.js. And then just start like writing some modern JavaScript where I'm importing underbar from Lodash, saying here, actually because I npm installed Lodash, we can give you statement completion. But then now I say underbar dot, and notice you get statement completion automatically. This is what's called automatic type acquisition, where we go consult at types and then suck down the type definitions and put them in a local cache automatically. And this is our language service doing this. But this is on a JavaScript file. And now, all of a sudden, we can give you statement completion on a whole bunch of things. And if you go to definition, you'll see that, yep, this came from that declaration file, but you didn't actually have to do anything to get it. And let's say you are writing JS-doc annotations in your code, like here, @param string. This is me and my bad typing, but I'm getting there eventually. And then I write a function called len that takes an s. Well, now we trust that, yes, that's a string, and so we can give you statement completion inside that function. But of course, it's JavaScript. You can call it in pass 55. I mean, yeah, well, that's like, you might have meant that, right? I mean, or you could go and have a typo, and it's still valid JavaScript, right? But you could also tell us to, hey, why don't you check my JavaScript in a very conservative manner, but if you can tell that this is never going to work, then let me know about it. If you're not sure, then don't make noise. But it turns out in a lot of cases we can tell that that's never going to work, and then we can even give you like refactorings, allow you to rename, et cetera, and give you errors. So that's sort of a thing that we take really seriously is you know, like meet programmers where they are. Hey, if you want the full enchilada, you can rename your files to .ts and whatever, but if you don't, then that's fine by us. Okay, that's it. I hope I didn't go too bad over time. I wanted to maybe, like, just if I get to make some wishes here, I have a little list of things that I'd love for all of you to do. When you're writing in TypeScript, please use strict mode. How many of you use strict mode? Oh, okay, good. It is unfortunately not the default. We would like for it to be the default, but we would break a whole bunch of projects out there if we made it the default. So, but please use it. How many of you use the nightlies ever? The nightly builds? Oh, big appeal. Please try them out, because this is how we get better in the releases and how we don't have stumbles and whatever. It's like, so please check them out. And now with the new playground, it's much easier for you to do so with your code. How many of you file issues? Awesome. Please boil them down to less than 10 lines of code. And please make sure it's not a question, and if it is, then put it on Stack Overflow. Also, vote on the suggestions out there. It is actually a great indicator for us as to where does the community want to go. So if you see a suggestion up there, or if you have a suggestion, put it up, and then please vote, because it guides us when we go look at what to do. And then finally, please help out on Stack Overflow. There's a lot of questions about TypeScript, and you guys are the smart guys, so go help out there. And that's it. I want to thank you for being here, and I hope and I look forward to the rest of the conference. Thank you very much. Thank you.